Good morning, grade 9 students. I am Sir Ibarra here and welcome in our math class. Our topic for today is about nature of the roots. The objectives of this lesson are the following. The learners will be able to A. Characterize the roots of a quadratic equation using the discriminant, and B. Solve for the discriminant of the given quadratic equation. Before we proceed in our topic for today, let us have first a simple review of your past lesson. The direction is evaluate each expressions. For number 1, 3x minus 2 for x is equal to 3. The first thing that we need to do is substitute the value of x as 3. It will become 3 times the quantity 3 minus 2. 3 times 3 is 9 minus 2, and it is equal to 7. Let us have number 2. 4x plus 10 for x is equal to 5. Again, by substitution, it will become 4 times 5 plus 10. And 4 times 5 is 20 plus 10. The answer is 30. Let us have number 3. 5x squared minus 6x plus 8 for x is equal to 4. Again, let us substitute the value of x as 4. It will become 5 times the quantity 4, quantity squared, minus 6 times 4 plus 8. Let us answer first the exponent. 4 times 4, it will become 16. After that, let us multiply negative 6 times 4, and the answer is negative 24. And it will become 5 times 16 minus 24 plus 8. And 5 times 16 is equal to 80. So 80 minus 24 plus 28. 80 minus 24 is 56. Bring down 8. So the final answer is 64. So let us now discuss our topic for today about nature of the roots. The nature of the roots can be decided by using the quantity b squared minus 4ac, which is called the discriminant of the equation ax squared plus bx plus c equals 0. Thus, in this case, we have 4 cases. If b squared, or if the discriminant b squared minus 4ac is equal to 0, the roots are real, equal, and rational. What about the second case? If the discriminant b squared minus 4ac is less than 0, the roots are unequal and imaginary. For the third case, if the discriminant is greater than 0 and the discriminant is also a perfect square, the roots will be real number, unequal, and rational. And for the last case, if the discriminant b squared minus 4ac is greater than 0 but not perfect square, the roots are real, unequal, and irrational number. Let us have now the first example. Example number 1 is x squared minus 5x plus 4 equals to 0. In this case, I will be using the quadratic formula. The first thing that we need to do is identify the values of a, b, and c. And a is equal to 1, b is equal to negative 5, and c is equal to 4. Applying the quadratic formula, let us substitute each values. And it will become negative times the quantity negative 5, positive negative square root of quantity negative 5 quantity squared minus 4 times 1 times 4 all over 2 times 1. And let us now simplify. Negative negative sign times negative 5, the answer is positive 5. What about the numbers inside the radical sign? It will become negative 5 times negative 5, the answer is positive 25. Negative 4 times 1 times 4, the answer is negative 16. What about in the denominator? 2 times 1 is 2. So the equation will be x is equal to 5 positive negative square root of 25 minus 16 divided by 2. And what is 25 minus 16? The answer is 9. And 9 is an example of perfect square number. So let us simplify it now. It will become x is equal to 5 positive negative 3 divided by 2. Let us now have the x sub 1. X sub 1 is equal to 5 plus 3 divided by 2 is equal to 8 divided by 2, and 8 divided by 2 is 4. And that is our x sub 1. What about x sub 2? 5 minus 3 divided by 2 is equal to 2 divided by 2 and is equal to 1. Let us have the second example. We have x squared minus 10x plus 25 equals to 0. Again, using the quadratic formula, identify the value of a, b, and c. A is equal to 1, b is equal to negative 10, c is equal to 25. Using the quadratic formula, and let us substitute, it will become negative times the quantity negative 10 positive negative square root of quantity negative 10 quantity squared minus 4 times 1 times 25 all over 2 times 1. Let us now simplify. Negative times negative 10, the answer is positive 10. Positive negative square root of negative 10 times negative 10, the answer is 100. After that, let us multiply negative 4 times 1, negative 4 times 25, the answer is negative 100. What about in the denominator? 2 times 1 is 2. After that, let us now simplify the number in the radical sign. We have 100 minus 100, and that is equal to 0. And what is square root of 0? The answer is 0. So now we have x is equal to 10 positive negative 0 divided by 2. For our x sub 1, it will become 10 plus 0 divided by 2. 10 divided by 2 is equal to 5. And that is our x sub 1. What about our x sub 2? 10 minus 0 divided by 2 equals to 10 divided by 2. And it is also equal to 5. Let us now have the third example. We have x squared minus 8x minus 4 equals 0. Identify the value of a, b, and c, because in this case, we are still going to use the quadratic formula. A is equal to 1, b is equal to negative 8, c is equal to negative 4. Applying the quadratic formula, let us substitute the values of a, b, and c. It will become negative times the quantity negative 8 positive negative square root of quantity negative 8 quantity squared minus 4 times the quantity 1 times negative 4 all over 2 times 1. Let us now simplify. It will become negative times negative 8, the answer is positive 8. Positive negative square root of negative 8 raised to 2, the answer is 64. Negative 4 times 1, negative 4 times negative 4, the answer is positive 16. After that, let us add 64 plus 16. The answer is 80. In this case, our discriminant is not a perfect square, but it is greater than 0. Let us continue. In this case, all we have to do is find the factors of 80 that has a perfect square. And 80 will become 16 times 5 because 16 is a perfect square. And we can now simplify it. And what is square root of 16? We have 4. We are going to write that, or we are going to place that outside the radical sign. Our equation now is x is equal to 8, positive negative 4, square root of 5, all over 2. If you will notice, we have common number, or we have common factor in 8, 4, and 2. And that is 2. Let us now simplify. Let us divide 8 by 2, and that is 4. 4 divided by 2, and that is 2. And 2 divided by 2 is 1. We will not write 1 anymore, because any number divided by 1, the answer is the number. After that, our x sub 1 will become 4 plus 2 square root of 5, and our x sub 2 is 4 minus 2 square root of 5. Let us now have the fourth example. We have x squared minus 4x plus 7 equals to 0. Let us now identify the values of a, b, and c. A is equal to 1, b is equal to negative 4, and c is equal to 7. After that, let us apply the quadratic formula. And let us now substitute the values of a, b, and c. We have negative times the quantity negative 4, positive negative square root of quantity negative 4, quantity squared minus 4 times 1 times 7 divided by 2 times 1. Let us now simplify. We have negative times negative 4, we have positive 4. Positive negative square root of negative 4 times negative 4, we have 16. After that, negative 4 times 1 times 7, the answer is negative 28 divided by 2 times 1 is 2. After that, let us simplify the number inside the radical sign. We have 16 minus 28, and the answer is negative 12. In this example, our discriminant is already a negative number. If that is the case, the roots are imaginary number, or there will be no real roots if our discriminant is a negative number. Let us now have the summary of our discussion. We have, if the quadratic equation is x squared minus 5x plus 4 is equal to 0, the discriminant is 9, and 9 is a perfect square, and at the same time it is greater than 0. Our roots 4 and 1, if you will notice, they are real numbers, unequal, and at the same time they are rational numbers. What about, for example, number 2? X squared minus 10x plus 25 equals 0. Our discriminant is 0, and if our discriminant is 0, the roots will always be equal. In this example, we have 5 and 5. So the nature of the roots will always be real numbers, equal, they are the same, 5 and 5, and at the same time, rational number. What about example number 3? X squared minus 8x minus 4 is equal to 0. Our discriminant is 80, if you will notice, it is not a perfect square, but greater than 0, our roots will become real number, unequal, and at the same time irrational number because of the radical sign. And for the last one, we have x squared minus 4x plus 7 is equal to 0. Our discriminant is a negative number. We have negative 12. So it will become imaginary number. The nature of the roots is imaginary number, or no real roots. At the same time, they are unequal. So that will be all. I hope you learned a lot from our lesson for today. God bless everyone and see you next time. Goodbye.